Hi again, guys. This is introductory sessions for Venom developers. And in previous video, we paused at setting up our developer environment. So now we have Locklift installed. We have VS Code extension to have pretty syntax highlighting for our smart contracts. And we have a wallet. In this video, we will build our smart contract. We will compile it and have a binaries. We will see what build artifacts it generates. We will also run deployment script and deploy it to Venom testnet. And we will run tests for our smart contract so that we are sure that it works well. Also, we will examine some pretty good developer tool called tools.venom.rs, which allows you to debug your smart contract and interact with that, so it's auto-generated UI. I'll show it a bit later. And one thing I forgot to mention in previous video is that if you like JetBrains IDEs, we also have the plugin for TSOL for syntax highlighting and code navigation for JetBrains IDEs. So feel free to visit the plugins marketplace at jetbrains.com and find TSOL plugin and install it if you like this IDE. But these sessions will be conducted in VS Code. I think it's a bit more adopted throughout developer community. So we will proceed with that. I want to remind you guys that you are highly encouraged to subscribe to our socials. You can find it at venom.foundation so that you will be up to date with news and announcements regarding testnet launch and mainnet as well. Also, we have a pretty vibrant community at Discord channel, and there is developer chat where you can ask questions, and I'm around here and I'm happy to answer that. So yeah, feel free to ask any questions basically. Yeah, so the first thing we need to do to deploy and to touch the testnet is to get some tokens. So go to faucet.venom.foundation and proceed with following steps. So I'm going to log in with GitHub. I already have this authorization set up, but yeah, so you will see a pop-up which will ask you to log in with GitHub. I hope you are comfortable with that flow. Then you will need to paste your address here, choose the tokens amount you want, and write some reason for request, because for now all the requests are handled manually. So we want to be sure that testnet tokens go to right hands. So you basically can type something like hackathon 2023 and get your portion of tokens, check some captcha and request testnet tokens. Alright guys, let's check our wallet. Hooray, we have 100 tokens here as requested. So now let's go to coding. Let's go to our IDE and open locklift.config.ts to see what's inside here. So we have some configuration for testnet. The configuration basically starts with compiler configuration, where you need to set up version of your compiler and linker. This is a tool chain for building binaries of your contract. And once you specify the versions, they will be downloaded automatically on the first build, and then that version will be used to compile your contracts. The second section is networks. So as usual, we usually have several networks. Basically, when you develop for EVM, you have the configuration for example, for BNB chain, for Ethereum, for Polygon, etc. And we have that as well. So we have configuration for local network, for testnet, for Venom testnet, for Venom mainnet, and for other TVM compatible networks as well. For now, we are interested in Venom testnet, and let's see what's inside here. So the configuration layout is basically the same for any network, and the important sections here are connection, giver, and keys. So the connection is basically the type of RPC that you will use. So there are two types of RPC: the gRPC, which is which is basically the HTTP interface, which proxies the request rights to the node, and the second type is GraphQL interface, like we have on local network. I think that we will have the GraphQL interface for Venom testnet as well, but for now we use gRPC. So GraphQL provides you more fancy interface with indexing, with some fancy requests, so you can filter, you can paginate, you can request transaction history in batches, etc. And gRPC is basically an interface which provides minimal API to interact with smart contracts. So we will use gRPC in this tutorial, and you shouldn't even think about that, because Locklift provides the abstract interface around these providers, so everything is possible with any provider. So you can send messages, you can call methods, you can read data from contracts, you can make any actions basically with your smart contract system. The second section is giver. So the giver is a smart contract which will fund all your deployments, because to deploy some smart contract to the network, you need to spend some gas, obviously, and you need to put this tokens on the future address of your smart contract. We will see how it's done a bit later. So here you just need to insert your wallet address and your seed phrase, and when it goes to production, you don't want to put phrase right here. So usually you will pick up some package like .env and put your phrase in some .env file, which you will not include in your GitHub repository. But for this sessions, we will just insert seed phrase like right here, because we are not aimed to deploy something to production. The next section is keys. So usually when you're writing some test scenarios, you want to emulate behavior of several users which have several roles inside your system, and you want to generate keys for each user, separate keys, so that you can test different scenarios. So here we generating 20 keys, and then in our test scripts we can refer to them by indexes like 1, 2, 3, 4, etc. Also, if seed phrase don't specify the keys, the phrase will be generated automatically, and all other keys will be derived from this phrase. But you can specify the phrase explicitly, so that all your keys will be deterministically defined in your tests. So that's basically how it works. So we are happy with such setup. Just need to paste our wallet address here, so that we can fund our deployments with gas. Right. I don't remember my phrase, so I need to go manage seeds, my seed, export seed, type in my password, and copy all words and paste it there. Alright, we are ready to go. Now, what we have in our folder here is contracts, scripts, and tests. So we have simple deployment script here, but before we deploy, we need to build our contracts. So for that we will use npx locklift build command, which will call the compiler backend and generate some build artifacts. So here we see the build folder appeared, and the most important files here are ABI, which is a JSON file with definitions of all functions and all events and all fields that your contract have. And the second important file is TBC. This is a binary for your smart contract. If you have several contracts in your system, the build command will build them all. So you just need to call it once, and it fill in the build folder with all build artifacts for all of your contracts. It will also generate some wrapper, TypeScript wrapper around the ABI, so that you can so that inside the scripts you can have let me show you. You can have this code completion with all your methods, and it will also suggest you parameters which you need to pass inside your methods. So it's pretty convenient, and you don't need to jump to contract code and check what variable you should pass, or how the methods are called, etc., etc. It is the typing is auto-generated from ABI. So yeah, so let's run our deploy script. But the first, let's go through it to understand how it works. So the first thing is that we need to get the key with which we will sign the deploy message. So we have 20 keys, as you remember, and we will get the key by index 0 and remember it here. Then we will call locklift.factory.deploy contract function, which will do everything to deploy your contract. So the contract deployment process is very simple. At first we will calculate the future address of our contract, because it's calculated deterministically. Then we will send some tokens from giver to this future address, and then we will send external message to this address with our binary with code and initial state of our contract. So in the parameters of deploy contract function, you just need to specify the name of your contract, and it also suggested by IDE because of TypeScript magic. We specify the public key with which we sign the message. We specify the initial params for our contract, and this initial params correspond to the static variables of your contract. So we have one static variable called nonce, and basically the future address depends on static variables and on code. So by changing this static variable, you will get more and more future addresses, so that you can deploy several instances of your contract to different addresses. That's how it works. So we generate random nonce, and we use random nonce because if we want to iterate and make several deployments, we want the nonce to change so that the future address changes, so that we have newer and newer instances of our contract. And also we specify the constructor params, which where we have only initial state variable, and we specify the value which will be the initial value for this address. So we specify 3 tokens here. So we now have 100 tokens, and let's spend not 3 but 1 token here. And also we have console message with the address of the contract, so that so that we know what the address of our deployment is. So let's run the script. npx locklift run -s, which is a parameter to specify the path to our script, and -n, which is a parameter to specify the network. So our network is Venom testnet, and let's check it out. Okay, so it knows the giver balance is 100 hours, so we are sure that locklift picked up our wallet, and we just need to wait a few seconds while the message will be processed by blockchain. Right, so we have the address. Let's go to Explorer and check what we have here. So here we have a little bit less than 1 Venom tokens on the balance, because the portion of tokens was spent to actually deploy our contract. And we have some messages, incoming messages on this address. We have 2 transactions, and let me explain why we have 2 transactions. So the first transaction was funding of the future address with 1 token, and the second transaction was a result of our deploy message. So the deploy message has encoded constructor call in it, and as a result we have a transaction which spends some portion of tokens to initialize the account with code and data of our contract. One more interesting thing here is that we also can have we also have decoded constructor call, so that we know which parameters were used to call this contract. And the interesting thing is that if we will click on the message hash, we will see on the bottom of the page, we will see the diagram of what happened after this message was processed by blockchain. So we have a message coming from our wallet, our giver wallet, to this address, and we see like the full graph of the whole chain of transaction. So we send an external message to our giver wallet. We call the send transaction method on our wallet, because the wallet is also a smart contract. Then the wallet sends a message to a future address of our contract with 1 Venom and funds it. The second thing is that if we go to our deployment transaction, we can open the diagram tab here and see that our second transaction was an external message to our sample smart contract with constructor call, and the sample contract emitted an event with state change, because in our smart contract code we have this set state call inside the constructor function, which in turn emits an event of state change. So this is all reflected on the diagram in the Explorer. So pretty convenient to debug your stuff when you send a message and it produces some chaotic mess. If you have complicated system, you can always go to Explorer and see on the diagram the whole flow of your messages between different contracts in your system. Let's examine another tool which called testnet tools.venom.rs. So here we need to connect wallet. Let's connect our wallet and put in our contract address. Right. So on the left we see the transaction history to this contract with all details and some debug information about all the messages. And if we load the ABI here, so I will call it sample ABI, I'll copy paste it from here, and if we load it here, we will see that it generates the UI for our smart contract. So we can interact with our contract with this interface. So let's, for example, try get details function. So we run it locally and we see the output state is 0. So let's set the state, for example. For that, we need to send external message to our smart contract. So let's set the state to 42, for example, very famous number. I'll type in my password as usual. Wait a few seconds. And see the details of resulting transaction. And on the left, I see that the full information about what happened. So I see that the function was called with parameter 42, and the event was emitted with 42 basically. And then if I run this function, I will see that state changed. It's now 42. Right, guys, so that's all, and in the next video we will try to modify our smart contract, play with it a bit, and we will also dive in a bit deeper to what kinds of messages could be sent to blockchain, because there are a few kinds of messages, and we will also examine this tool deeper, because it has like several buttons, and you need to know which button you need to push in what situation. So yeah, see you in the next video.